This video covers section 1.2 in the textbook, which is called Methods of Enumeration, which really just means that we're going to talk about counting. And counting always sounds like something that we've learned how to do a long time ago, but counting can actually become very challenging very quickly. We're just going to talk about the basics of counting. So first I want to just talk for a second about why counting is important in probability. Remember that if we have an outcome space where all of the outcomes are equally likely, then we can talk about the probability of an event A occurring as being equal to the number of outcomes in the outcome space in which A occurs, divided by the total number of outcomes in the sample space. So being able to count the number of outcomes is going to be a useful skill when we are calculating probabilities. So the most basic place we're going to start with counting is the multiplication principle. And what the multiplication principle says, if there are n possible outcomes for experiment E sub 1, and there are m possible outcomes of random experiment E sub 2, then if we perform E sub 1 followed by E sub 2, there are n times m possible outcomes for them together. So for example, we could think about how many different creamy orders are possible at a creamy stand. If the creamy stand sells 3 sizes, small, medium, and large, our first random experiment would be the choice of size, and there are 3 possible outcomes. Then we can choose a cup or the cone for the second experiment. 2 possible outcomes. Maple, vanilla, or twist could be the flavor, so there are 3 possible outcomes there. And then we have the choice of chocolate sprinkles, rainbow sprinkles, chocolate dip, or no topping at all. There's 4 choices there. So how many total creamy possibilities are there? Well, we're going to choose one of the 3 sizes times 2 choices for the cup or cone times 3 choices for the flavor times 4 choices for the topping gives us a total of 72 different creamies that could be ordered at this creamy stand. Permutations are ordered arrangements of things. So if I want to know in how many different orders I can arrange the letters A, M, B, K, and Z, I'm really asking how many permutations there are of these letters. Now when I'm trying to answer this question, I'm going to use the multiplication principle. I'm going to start by choosing one letter, and for the first letter, there are going to be 5 choices. The next experiment, if you will, would be to choose the second letter. One of the letters will have already been chosen, so there'll be 4 choices left for the next letter. Then I'll choose the third letter, for which there'll be 3 choices. I'll choose the fourth letter in order, for which there'll be 2 remaining choices. And finally, I'll choose the last letter, and there'll only be 1 left. So there'll be 5 times 4 times 3 times 2 times 1 different possible ordered arrangements. And notice I've got the numbers 1, 2, 3, 4, 5 here, multiplying them by each other. This is 5 factorial, which is equal to 120. So in general, if there are n items, there are n factorial ordered arrangements that can be made of them. Sometimes we might want to make ordered arrangements without using all of the items. So for instance, in this situation, I'm going to be interested in how many different ordered arrangements I can make using only 3 of these letters. So I've got 5 letters, but I'm only going to use 3 of them. So again, we're going to think about the multiplication principle. I'm going to make 3 choices. For the first one, I'm going to have 5 possible choices. For the second one, there'll be 4 remaining choices. And the third, there'll be 3 remaining choices. So altogether, that's going to give me 60 possible ordered arrangements that can be made using 3 out of these 5 letters. Now, in general, we use the notation NPR. So this would be 5P3. I'm permuting 3 out of the 5 letters. And we can calculate the number of ordered arrangements by taking n factorial, so 5 factorial, divided by 5 minus 3 factorial. And that would give us 120 divided by 2 gives us 60. So that's the general formula that can be used to count the number of ordered arrangements that can be made using R out of n items. Now, sometimes I might be working in situations where not all of the items are distinguishable from each other. For instance, if I want to know how many different orders, I can arrange the letters E-L-E-C, T-R-I-C in. Notice here that I've got 2 E's and 2 C's. And so I could potentially say, well, let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8 letters. And so I think, well, I could arrange them in 8 factorial orders. But keep in mind that it doesn't matter which E I put first and which one I put second, or which C I put first or which C I put second. Those are going to look identical. So if I'm trying to think about the number of distinguishable ordered arrangements I can make, I'm going to need to divide this by the number of ways that I could order the E's times the number of ways I could order the C's. So this is going to give me 8 factorial is 40,320, but I'm going to divide that by 2 times 2 is 4. Which gives me 10,080. So just generally, if I've got any indistinguishable items, I'm going to count how many I have of each type that there's more than one of, and divide by those numbers. Combinations are unordered subsets. So for instance, if I ask how many different unordered subsets of 3 letters can be selected from the letters A, M, B, K, and Z, I'm asking for how many combinations of 3 letters can be made. Now, in order to do this, to figure this out, I'm going to start by figuring out, okay, well, I already know how many ways I can select 3 letters in order, right? That was my 5 times 4 times 3 was the number of ordered arrangements I can make out of 3 out of those 5 letters. And then, so this is the number of ordered arrangements. But how many ways could I arrange these in order? Well, I'll have 3 choices for the first one. So there are 3 factorial ways that I could order those 3 numbers. And since I don't care about the order, I don't want to count those as different things, so I'm going to divide by the 3 factorial. So this is going to give me 5 times 4 times 3 gives me 60. And I'm going to divide that by 3 factorial, which is 6, and it gives me 10 possible unordered subsets. In general, if we have n objects, the number of unordered subsets of size r can be formed. We use the notation NCR. Here, n is 5. We're choosing 3. Notation also can be used this way with this binomial coefficient, 5, choose 3. These are 2 equivalent notations. This is going to be equal to n factorial, here that's 5 factorial, divided by r factorial, that's 3 factorial, times 5 minus 3 factorial, gives us 5 factorial divided by 3 factorial times 2 factorial. And that again is going to give us 10. All right, so I'm going to put this together and look at if we were to purchase one Powerball ticket, what is the probability that you will win the jackpot? So the way that Powerball works, you start by choosing 5 numbers from 1 to 69, and then you choose one Powerball between 1 and 26. So I'm choosing 5 numbers from 1 to 69. It doesn't matter if I get them in the right order or not. So order is not important here. So here I'm going to be choosing without order mattering. So I'm going combinations. I've got 69 possible numbers and I'm choosing 5 of them. And then I also am going to do a second choice. I'm going to be choosing the Powerball, which there are 26 possibilities for. So using the multiplication principle, I'm going to have 69 choose 5 times 26. This is going to give me 292,201,338. So the probability of winning the jackpot is that you have one number out of 292,201,338 possible outcomes. That's the probability of winning. So pretty unlikely. Now I will just mention that if you have a graphing calculator like a TI-83 or TI-84, there are functions in your calculator that do all of these things. There's an n factorial. There is an NPR for permutations and an NCR that will do the combinations calculations. These are all in the math key under probability. And if you have one of those calculators and you don't already know how to use those functions, then you could go to YouTube and search and you'll be able to find videos that will show you just how they work. If you have any difficulty, just let me know and I'm happy to try to help you. Thanks, have a good day.